This is just an idea on how to use G-forces to move a spaceship and use G-forces to power it. If I had this, if I had a habitat ring, this would be a habitat ring with several floors in the center, had this out on one end, and had something like this in between the habitat ring and what I'd use to move it. This would be like this, let's just say 21 foot, 21 foot, 42, 42 foot, and 42 foot, and 21 foot. If this was like, let's say 200 foot at a common hub, this is spin one way, this is spin the other way, and this is spin the other way. If I had three wheels in space, this would have something like this. There would be a bunch of these out, maybe a couple hundred foot, would have containers of air spinning at several G's. This would be outward. This would be the center, where I'd seal this off. I'd have where I'd have water in here and air. Okay, I'd have a weight here. I'd have weighted, like maybe water or something didn't freeze. I'd drop this out this way. I'd have, if you stood on the scale at 5 G's and dropped it, it'd be this coming out this way, it'd be light this way. So you'd move that way. So if you drop it this way, here, you drop these, so these would drop this way. So the water in here would come around here, this would drop this way. You'd open these rings up, the water in here would come out here, they go up here. The water in here would fall this way, this would come in here, this would drop this way. So this air would come down, the water in here would come out, and this all would fall this way. So you'd have this weight falling this way, this water in here falling this way, you'd have these sealed. The water in here would fall, the water in here would fall, and this water in this tube would fall. So you'd have two of these. You'd have the one here, the one here, the wider one here, the wider one here, the wider one here, and the wider. You'd have all these fall on one side. On the other side, as this is spinning, it wouldn't all happen at the same time. It wouldn't all happen at the same time. On the other side, as this is picking up, on the other side, when you slid these rings up, you'd pick this up, but here, when you open this up, the water here would come down, and the water in here would come up. The water would come down, the water would come up. They would equalize, but this would come up. So you'd pick the weight up, water here, and water here, they'd equalize, so you'd be picking the weight up. So at 5 G's, there'd be like a 10 G difference. There'd be a 10 G out of balance here, but you'd have equal here, but you'd have in here, there'd be a difference. So you'd have the habitat ring, and then you'd have two of these out on each end. You'd have the habitat ring. Then in between that, you'd have something like this. This looks odd. This would probably be this way, but you may have, 10 or 15 of these, and these be in such a way these would be like a section of air, a section of water, a section of air, maybe a couple 100 foot up, 10 foot at a time, and down at the bottom, you'd have it sealed where water would go back and forth to the bottom, up a little ways, while liquid would go back and forth. When one came down, water would go across the bottom. When one came up, water would go across the top. You'd have rings that slide down, and they'd let water in under the air. So on one side, the ring would slide down, water on the outside. This is like let's say, if this was 300 foot across and 100 foot in the center, a ring would slide down, water couldn't get in under the air on one side. Over here, a ring would slide up, and water could get in under the air. So where water couldn't get under there, there'd slide down. Where the water could get under there, there'd come up. So it'd be out of bounds. There'd come up on one side, the water go down on the other, and at the bottom, water go back and forth. So if this was up, if you had these in between the habitat ring and where you're out of bounds to move it, maybe you could get power out of this. So on the outside of this, when these are coming up and down, back and forth, the water around it would never really move. Although these are coming up and you'd be getting power when the air's coming up and down and the water's coming up and down, you'd be getting power out of you'd be getting power when, like, if this was 100 foot across, you'd have like a 10-foot section, 100 foot of air, a 10-foot section, 100 foot of water. The weight of the water lifting power of the air as it came up and down, you'd have all that power, plus it may be 20 G's as this is spinning off this common hub in between here and here. These would be in the middle. They may be like that in the middle, in between here and here. It'd be here and here, where this would be on one end, and on the other end there'd be two of these, and maybe a wide one of these. I don't know whether these would give you power. These may be spinning at 20 G's. These may be spinning at 4 and 5 G's. Each one of these floors would be spinning independently at 1 G. You may have one floor for living on and several floors for growing food. The whole thing may be encased, so you're protected from radiation. And I don't know whether this would give you enough power to run it, whether this would be out of balance enough to move it, and whether this would give you power to run it.